Hello, my dear students. Welcome back to the session. Now, let us look at, because last class we have discussed parallel combination of two-port networks, and we concluded the overall Y matrix is sum of individual Y matrices. Okay. Now the fourth one is hybrid combination. In that hybrid combination, A, input side series and output side parallel. B, input side parallel and output side series. Okay, so generally you deal with H parameters in this case, and here G parameters. It is more comfortable to deal with that reduction of the network. And the overall H matrix is sum of individual H matrices. I give you conclusion here itself because I told you already. In case of cascade, it is product of individual transmission matrices. In case of Z, Y, H, G and all this, sum of individual matrices. Here sum, that is product. Understand all of it? Okay? Well, so I just give the what you call the connection of the hybrid combination, but I don't derive. I give the conclusion directly because already we did this same thing in Z and Y parameters. I mean series and parallel combination. Understand all of you? Okay? So I think you people can manage easily because already I have derived. Okay? So H parameters. First A, input series, output parallel. A, input series and output parallel. This is the first two-port network, Hx, Hy. This is the matrix. 1, 1 dash, 2, 2 dash. 1, 1 dash, 2, 2 dash. Now the series combination, this is a series combination. Input side, already we have seen what is the series combination. And this is a parallel combination. Output side, parallel combination. Two dash. 1, 1 dash. Already have. So this overall two-port network is replaced by, the resultant is replaced by, the reduction is replaced by a single two-port network. So what is the overall two-port network you get? H is equal to Hx plus Hy. If there are n number of two-port networks connected like this, right, and all, then you will get sum of all individual H matrices. I hope you understand. Okay. So next B. What is B? Input parallel and output series. So I think I don't need to draw because you understand it directly. The same combination you take this side and that combination you take this side. That's all. Okay. So this side parallel, this side series. So I think you can do that. I'm giving that work to you only. So what is the resulting G matrix? Gx plus Gy plus and so on Gn. This is the resulting G matrix. Understand all of it? Okay. So you can take down that quickly and we'll move on how to really find the parameters. Okay. How to really find the parameters. How to determine parameters. Please note down quickly that one. how do you find the parameters? How to determine the parameters? There are different approaches. There is no unique procedure to find the parameters. Different approaches depending upon the problem given. You will understand after doing some problems, after going through certain problems, you will understand which method suits for a given problem that you will decide. Okay. So, but I will give you different methods here. Method 1. Okay. Method 1 is from the definition of or by defining the parameters or from the definition of parameters. From the definition of parameters. How you define the parameters? Z11 is equal to V1 by I1 when I2 is 0. This is how you define the parameters. So from that definition of parameters, by applying the conditions, you are defining the parameters. So from the definition of parameters or else from the conditions, you can find in one method. Okay, the first method. Second method is that use star delta transformation. Okay, use star delta transformation. Yes, if a given two-port network is replaced by an equivalent star, Z parameters can be easily determined. Okay, and if the given two-port network is replaced by a pi model, then Y parameters can be easily calculated. Understand all of you? Okay, I will tell you how it is going to be. Right. Method 3 is using mesh analysis or node analysis. Using mesh analysis or node analysis. Okay. Here, delta to star, I'll put it here something like this. Delta to star, that means the final result is star for Z parameters. And star to delta, that means you are finding the resulting two-port network as pi model. Because delta and pi both are same, yes or no? Delta and pi both are same. Star and T model both are same, yes or no? Because star looks like T only. Okay. So for Y parameters, this is for Y parameters. Mesh analysis is used usually for Z parameters. It is easy to find Z parameters. Node analysis is usually applied to determine Y parameters. So I hope you understand this. So once you get Z, Y parameters, you know how to find other parameters also. Yes or no? Okay. Therefore, these are the three methods which can be applied to determine parameters from the definitions or conditions. Okay, from the definitions of the parameters or conditions that you apply to define the parameters. One method, star delta transformation, mesh or node analysis. Understand all of you? Okay. So if you want to find Z parameters, better you choose mesh analysis. It is more comfortable for you. If you want to find Y parameters, go for node analysis. If you want to find Z parameters, use delta to star transformation and finally you replace by star nothing but T. You will get directly Z parameters. If you have or if you need Y parameters, then use star to delta transformation. Finally, delta is resulted, but delta is nothing but what pi model only. So you can easily find Y parameters. I hope you understand this. Okay. So T model is more comfortable for Z parameters. Pi model is more comfortable for Y parameters. Once you know these parameters, you know how to find the remaining parameters. Okay. Now, let me take an example. Number 1, problem number 1. First problem. Let's find Z parameters for this T model. Clear? 1, 1 dash, 2, 2 dash. ZA, ZB, and ZC. I apply all these three methods, I'm telling you. Okay? Now, method 1 says from the definitions, Z11 is equal to V1 by I1 when I2 is 0. Z21 is equal to V2 by I1 when I2 is 0. Okay, let me apply these conditions to this network. What will I get? This is ZA, ZC, ZB, 1, 1 dash, 2 and 2 dash. This is ZA, ZB and ZC. Understand all of you? Okay. 1, 1 dash, 2, 2 dash. Now if you take 1, 1 dash, 2, 2 dash, let me connect a source here, V1, excite it by V1 and send some current I1. It should be I2 because I2 is made 0 here. And this value is what? V2. I hope you understand. Okay. Well, so this is V2. Now, from this we understand, we want Z11, nothing but input impedance. The impedance seen across 1, 1 dash. If you look into the network through 1, 1 dash, okay, since it is open circuited, this can be neglected. And you come from the rightmost side to simplify the network, how these were connected in series. So Z11 is nothing but actually V1 by I1 only, that we understand. But we also know that ZA plus ZC. Clear? Now another one is, so this one you got. Now another one is what? Z21. How do you define Z21? V2 by I1. That means V2 is equal to something into I1. What is V2? Here is the voltage. I1 is here. Can you relate these to V2 and I1? Yes, we can, because V2 is the voltage across ZC. Because there is no current flowing here, there is no drop here. The voltage here and the voltage here both are same. Clear? But what is the voltage across ZC in terms of I1, Nana? ZC into I1. So V2 is equal to ZC into I1. So from this we understand, okay, V2 by I1, nothing but what? Z21, nothing but what? ZC. Yes or no? Clear all of you? Okay. Well, so you got Z11 and Z21. Now to get another parameter, you make I1 0. If you make I1 0, you'll get other two parameters. So Z12 is equal to V1 by I2 when I1 is 0. Z22 is equal to V2 by I2 when I1 is 0. Understand? Okay. So what do you get here? Tell me. This is now ZA, ZB and ZC, 1, 1 dash, 2, 2 dash. This one is 0 now, I1 is 0. Now this is V1 plus minus V2 and I2. You can go for V2. Clear all of you? Okay. Well, now what is Z22? Z22 is nothing but, it is already V2 by I2, we know that, but it is the impedance seen across 2 and 2 dash terminals. When you look into the network through 2 and 2 dash, now come from this side, okay, come from this side, this is neglected. Yes or no? Here it is neglected. Now it is neglected here. Now these two are connected in series because there is no current flowing here. ZB plus ZC. Similarly, Z12 is equal to V1 by I2. Okay, or else you understand that Z12 is nothing but V1 is equal to something into I2. But what is V1? Voltage across these two terminals. Since there is no drop across because of open circuit, the same voltage will appear here. The I2 is flowing here. You can relate them. V1 is equal to ZC into I2. From this we understand V1 by I2, nothing but Z12, nothing but how much here? ZC. That's it. Okay, so I got Z matrix is equal to, okay, ZA plus ZC, ZB plus ZC, ZC and ZC. I hope you understand this. Clear all of you? Okay, so you can go with this. Now, second method. What is second method? Using star delta transformation. Okay, with the experience, we understand that once you are having a star model or T model, if the network is of T, because this is T section or T model, you get Z11. What is Z11? When you add these two, you'll get Z11. When you add these two, you'll get Z22. When you take this one, it is Z12 as well as Z21. And here the condition for reciprocity is satisfied clearly because there is no dependent source. Yes or no, all of you? Okay. So Z1 to Z1 both are same. So from the method 2, you must replace the given two-port network by an equivalent T model. But already T model is there. So if I just observe that this T model, once I construct T model, okay, here it is directly available. If it is not available, now you bring the T model by converting from delta to star. Okay. So what is this ZA, ZC and ZB? You add these two. You will get Z11. You add these two because from the past experience I am doing all these things. Okay. Z22, ZB plus ZC. You take this one, Z12, and you take the same thing, ZC. That's it. I hope you understand the point. Right? Method 3. Look at this. Don't write. I'll give you time. Method 3. To apply method 3, in method 3 I mentioned that mesh analysis and node analysis. Okay. For Z parameters, I told you to prefer mesh analysis. So therefore, to apply that mesh analysis, what we do is, here we don't apply any conditions, no reduction, no transformation, but we construct the network with all variables. This is 1, 1 dash. This is plus minus V1. Here it is I1. This is plus minus V2. Here it is I2. This is ZA, ZB and ZC. You understand? So this is I1. This is I2. Clear all of you? Let us apply mesh analysis. This is I1 already given. This is I2 already given here. So therefore, now can we apply inspection directly? This is V1 minus ZA I1 minus ZC of I1 plus I2 is equal to 0. This is V2 minus ZB I2 minus ZC of I1 plus I2 is equal to 0. If you rearrange, you will get the equation directly in the matrix form. Okay. So I do that inspection directly to get the matrix form. I know that sum of impedances in the first loop, ZA plus ZC, usually you get negative sign here the diagonal element in our inspection method what we discussed in the mesh analysis. But in this case, I'm taking reverse. So you follow reverse everything. Okay. Sum of impedances in the first loop, sum of impedances in the second loop. Yes or no? Common element in the first loop, a common element to the first and second loop. How the loop currents are flowing in the common element. Both are flowing in the downward direction. So same sign as the diagonal element. What is the diagonal element is having? Positive sign. Therefore, it should also have a positive sign. So ZC. And first row, second column is same as second row, first column. That is also ZC. Then into I1 and I2. And now it is touching negative sign. It should be taken as minus, but I'm following reverse convention. Therefore, it should be plus. Therefore, it is plus now. Plus V1. Touching negative sign. I'm following reverse convention, therefore it is plus V2. So it's very clear from this. If you compare these equations with the standard equations, how are the standard equations of Z parameters look like? Tell me. They are also V1, V2, Z11, Z12, Z21, Z22, I1, I2. Therefore, this becomes what? Z11. Yes or no? This becomes what? Z12. This becomes what? Z21. This becomes what? Z22. Yes or no? Okay. So finally you got it. So you can find parameters like this. First method, from the definition. Second method, convert the given two-port network into T model and just apply this method because already we know the answer how we got it. This method is called inspection, we can say. With the past experience we can do. Or else third method, mesh analysis. Clear? So please note down. Problem number 2. Find Y parameters for the given pi model or pi section. Okay. So now there are 3 methods, right? So method 1 from the definitions. What is Y11? I1 by V1 when V2 is 0. What is y21? I2 by V1 when V2 is 0. Understand? So let us apply this. V2 0, that means shorted. But you get some current I2 if you keep an ammeter here, yes or no? Because of the closed path, you'll get some current. So now let us excite it by some current source I1 plus minus V1. What is this? YC, YA, YB. I want Y11. Y11 is nothing but input admittance. This is called Y11 now because after shorting the terminals of 2, whatever the admittance that you measure across 1 dash, that will be defined as Y11 only. Once you short it, this is gone completely. And now YC and YA will be in parallel. Parallel combination of the admittances will give you sum of, right? The total resulting will be Y11 is equal to I1 by V1 is equal to sum of now that YA plus YC because these two are in parallel. Agree all of you? Okay. So I got one. Next one is what? I2 by V1. I2 must be expressed in terms of V1. I2 is equal to something into V1. That something is nothing but Y21. What is I2 here? The current flowing here. Can you expect any current in this one? No, because it is shorted. You can't expect any current here. The same current flows. The current flowing through short and current flowing through YC will be same. Can I find the same current in terms of V1? Because V1 is the voltage across this. Same voltage will appear here. Same voltage will appear here also. So what is the voltage across this? Plus minus. So this is plus minus V1. So V1 into YC will be the current flowing here in this direction. But I2 will be the current flowing here in this direction. Because I2 is flowing here like this. So I can equate now I2 is equal to minus V1 into, okay, YC. From this, I just find I2 by V1, which is nothing but Y21, which is equal to what? Minus YC. This is very, very important. Clear all of you, okay? Now, another definition is what? Y12 is equal to I1 by V2 when V1 is 0. And Y22 is equal to I2 by V2 when V1 is 0. Clear all of you, okay? V1 is 0. Now, getting all of you, okay? Now, what do you get here? Here you get, once you apply that condition, it looks like this. It looks like this. This is what? I2 to 2 dash. One dash. Now short it. V1 is equal to 0. YC, sorry, YA, YB and YC. Getting all of you, okay? Now what do you get here? When you take Y22, what is Y22 here? Y22 is nothing but I2 by V2, no doubt, according to the definition, no doubt. But Y22 is nothing but admittance seen across 2 and 2 dash when V1 is 0. When V1 is 0, this is got neglected. Some current flows here, I1. No doubt if I connect an ammeter, it reads some value. That current, I call it as an I1. So when you look into the network here, this is neglected. Now this YC and YB are parallel. So parallel combination, I can go for admittances addition only. So YB plus YC. I got it. Then I want to express I2 in terms of V2. I1 in terms of V2. What is I1? The current flowing here. This is also I1 now because you can't expect any current because of the short circuit. Got it? Same V2 will appear here. Same V2 will appear here and here because there is no element here. Plus minus V2 the same voltage. So what do you relate here? So I1 can be written as minus V2 into YC. From this, I1 by V2, nothing but Y12, nothing but minus YC. Therefore, what is Y? Y matrix is nothing but, okay, YA plus YC This is YB plus YC minus YC and minus YC. Is it clear, all of you? Okay. So this is how you generally, calculate the Y parameters. From this we understand easily that when the pi model is given, Y11 can be easily observed, right? Y12, Y21, Y22 can be observed easily. It's very clear. Yes. So that is why in method 2, we go for delta to star or star to delta. Star to delta. Finally, delta must be available. That means pi model. This is nothing but pi model. So already pi model is available. There is no need to now do any transformation because already you are given a pi model. If the given network is not of pi model, you have to convert that into pi model using the transformation methodology. Understand 1, 1 dash, 2, 2 dash. Okay. So Y can be calculated now. Y11, you add these two. YA plus YC. Add these two. Y22, YB plus YC. Now you already got YC minus YC. Y12 is not what? Y12 is equal to Y21. Both are same. Why? Because there is no dependent source. You know that condition for reciprocity. They are same. Okay, they are same. This is minus YC. Minus of this value. But make sure that all values are in admittances or conductances. Then only it is possible. So you must be very careful because generally in the exam, all values are given in ohms. So you first design a pi model, then convert all the values into Siemens or Mohs. Then you apply this logic. YA plus YC, YB plus YC, minus YC, minus YC. Two parameters you will get. Clear? Last one. Method 3. Look at this, all of you. Method 3. Method 3. For Y parameters, node analysis is always comfortable. Look at this. I'll tell you how. I'll prove it. I'll prove it that for Y parameters, pi model is more suitable to deal with. Node analysis is more suitable to deal with. 2 and 2 dash, 1, 1 dash. Okay, for Y parameters, node analysis is more suitable to deal with. Look at this. This is I2. What is the voltage here? V2. I'm just taking current source for my convenience. You can take voltage source also, doesn't matter. YC, YA, YB. Right? So if I take this one 0, node analysis, this is V1, this is V2. Yes or no? So what will you get here? What will you get here? I'll get, look at this, inspection let us apply. Sum of the conductances at this node. Yes, already you have. Sum of the conductance at this node, Y22. YB plus YC. YB plus YC. Negative of the diagonal element. Already diagonal element is positive. Generally in node analysis, I think if you remember, I have explained that inspection method. Minus of this value, common element to first and second nodes. What is that? Minus YC. And this element need not to be calculated again because already you know that off diagonal symmetry. This is V1 and V2. Now here you have this current is entering into the node. Entering current is positive in the inspection. So very clear if you compare all these things with your standard equations of the Y parameters. I1, I2 is equal to Y11, Y12, Y21, Y22, V1, V2. So this is Y11, this is Y12, this is Y21, this is Y22. Therefore, Y matrix is equal to YA plus YC. Okay, already got. There is no need to write, but this is what the Y parameters you get. So I think you understand that the pi model, Y parameters, there is a relation. Node analysis, Y parameters, there is a relation. T model, Z parameters, there is a relation. Mesh analysis, Z parameters, there is a relation. Understand all of you, okay? So immediately when the problem is given, these parameters can be easily calculated. So please take down this. We will move on to other problems. Quickly note down. Problem number 3. Determine Z parameters of the following bridge. Okay. There is a bridge model given, or bridge section is given, and we are asked to find the Z parameters. Okay. So how do you find it? Looking at this problem, which method is suitable, more suitable among the 3 available methods? The first one is what? Conditions or definitions you have to apply. For each parameter, you have to draw, or you have to apply the definition Z11 is equal to V1 by I1 when I2 is 0. Same time, you will get another parameter also for the same condition, because I2 is 0, Z11, Z21 can be defined. Similarly, the other two can be defined for when I1 is 0. That is one method. Or else star delta transformation or delta to star, because Z parameters, you require a star that is nothing but T model, so that you can easily find the Z parameters directly from the T model. Or else you have mesh analysis. Mesh analysis, if you go 1, 2, 3 loops are there, then you have to eliminate that extra current, that I3, then you will get it. So among all these methods, you will definitely get the solution, but I prefer for this, I think delta to star is more suitable. So if I just see that delta to star, look at this is star, but this is forming delta, yes or no? If I convert this delta into star, okay, if I convert this delta into star, look at this. Equal values are there. So 6 by 3, yes or no? Nothing but what? 2 ohm. Similarly, this is also 2 ohm. This is also 2 ohm. Yes or no? So what do you get now? Finally you will get this is 2 ohm, 2 ohm, and 2 ohm, and 3 ohm. 1, 1 dash, 2, 2 dash. Okay. So these two can be added. Nothing but 2 plus 3, that is 5 ohm. So I replace it by 1, 1 dash, 2, 2 dash. Yes or no? So when you add these two, you will get Z11, 2 plus 5. When you add these two, this is also 2 plus 5. When you take this one, this is same for both, right? 5 and 5. So 7, 5, 5, 7 ohm is a Z matrix. I hope you understand this. So it's very easy and save a lot of time. In the competitive exam point of view, when this type of networks are given, better you go for directly star data transformation. 3A, I just give you the network something like this. I want Y parameters. For these Z parameters, the question is Z parameters. Now the question is what? Y parameters. The same bridge model. Now this is 3, 3, 3 and 6 ohm. I want Y parameters for this. Clear? First you note on that and also note on this problem. Meanwhile, I just remove this. Now from this, the given network, you understand that star to delta transformation is much more suitable. I can apply node analysis, no doubt. I can apply the definitions and find the parameters. But when this type of networks are given, better you apply delta to star or star to delta. Here you're dealing with y parameters, therefore better you go with star to delta. Final result should be delta. Delta is nothing but what? Pi model. Okay, therefore, look at this. This is forming delta, but this is forming star. So let us go for star to delta transformation. So if you go with that, what we get? This is what star, but now I am getting delta. Right? So all are equal values, 3, 3, 3. Therefore 3 into 3, you get 9 ohm. This is also 9 ohm. This is also 9 ohm. Yes or no? So what is the final result you get? This 9 and 6 will be parallel, yes or no? Okay, 9 and 6 will be parallel. So 9 ohm, 6 parallel. 9 into 6 by 9 plus 6. So what do you get here? 9 into 6 by 9 plus 6 here. So you got, this is 15. 3 2 ja, 3 3 ja. Okay? So 3 5 ja. 3 2 ja, 3 5 ja. 18 by 5 ohm. So you get the parallel combination of these two. 18 by 5 ohm. And you will get this one as 9 ohm. This one has 9 ohm. Understand? Okay. But when you apply that logic, YA plus YC, YB plus YC, yes or no? Make sure that all values must be in Siemens, not in ohms. So can I write this is 5 by 18 Siemens? Yes, I can. This is 1 by 9 Siemens. Yes, I can. This one also 1 by 9 Siemens. Now I can apply Y matrix is nothing but adding these two. What do you get? 5 by 18 plus 1 by 9. Adding these two. 5 by 18 plus 1 by 9. Okay. Now negative of this value YC, right? So minus 5 by 18. Minus 5 by 18. Siemens. Understand all of you? Okay. So what do you get here? Tell me. The Y matrix will be. Y matrix will be. What do you get here? This is 2 by 18. That means 7 by 18. Yes or no? 2 by 18. 5 plus 2. That's it. I think you understand this, right? So what do you get here? 9 into 6 by 15. 3 2 ja, 3 5 ja. Okay? 18 by 5. The same logic I applied here and I get here 7 by 18 and minus 5 by 18 minus 5 by 18. That's it. So Siemens. So this is how you calculate the Y parameters for the given bridge model. So for the same bridge model, I found Z parameters and I found Y parameters. In first case, I preferred delta to star because I want Z, I want T, delta to star. Second, I went for what? Star to delta because I want pi. Delta is nothing but pi. No doubt. Fourth problem, find Z matrix of the given lattice model. Find Z matrix of the given lattice model or lattice section. A symmetric lattice section is given here. I'll prove it. It is symmetric. ZA, ZA, ZB and ZB. 1, 1 dash, 2, 2 dash. Okay. For this, we need to find Z parameters. Understand? How do you find Z parameters of the lattice model? There are three models. We have three methods. We have one is conditions. The other is star delta transformation. What is the last one? Mesh analysis because Z parameters. Okay. But I cannot really find a T model for the given the lattice model, because for T you require, for pi can be converted to what T model, no doubt in that. But is there a pi model that you have to convert? No. Let us rearrange this network, then we get a clear idea. Okay. So if I rearrange, look at this. This is 1 dash, and this is 2. This is 2 dash, let us say. 2 dash, and 1 dash. What are the elements connected between 1 and 2? ZA? What are the elements connected between 1 dash and 2 dash? ZA? What are the elements connected between 1 and 2 dash? ZB? Sir, no. Okay, ZB. And here also ZB. Yes or no? Okay. So you have 1 dash, and you have 2 dash. Okay, this is 2 dash. This is 1 dash. This is what the two-port network is available with you. Understand? Okay. Between 1 dash, 2 dash, all those elements are connected like that. This is reconstructing the given lattice model. So definitely started the transformation doesn't work because you don't have any delta to convert to star. You can either go for the definitions, first method, or you can go for what? Mesh analysis or node analysis. Mesh analysis, not node analysis, definitely. Okay. Now, if you just look into this network with all variables, can I connect like this? These are the variables, V2, I2, V1, I1. Yes or no? Now let us apply either mesh analysis or else conditions or definitions. First method says that you apply definitions or conditions, okay? So these are the 3 loops. 3 loops, in that 3 loops, if you apply and KVL and get some equations and remove the unwanted variable, then you will get the resulting equations. Those resulting equations can be compared with the standard equations of the Z parameters. But I'm not really preferring that method. I can do that, but I'm not preferring. I'm preferring the conditions. So conditions are definitions. What is that? Method 1 says Z11 is equal to V1 by I1 when I2 is 0. Okay. And Z21 is equal to V2 by I1 when I2 is 0. Clear all of you? Okay. Well, now let us apply that conditions here. I2 0. When I2 is 0, what do you get here? It is something like this. This is ZA, ZA, ZB, ZB. The I2 0, right? I2 is 0. And this is what V2. This is 2 dash. But you have plus minus. This is 1. This is 1 dash. This is V1. This is I1. Understand all of you, okay? What is Z11? You already know that V1 by I1, of course, but Z11 is nothing but input impedance looking into the network through 1 dash terminals. It's already open. If it is open, then these two are in series, these two are in series, then the resulting is in parallel. So therefore, ZA plus ZB, this one, these two are in series. These two are also in series because this is an open circuit. I2 made 0. Parallel with ZA plus ZB. Finally, you got ZA plus ZB by 2. Clear, all of you? Okay. Now, Z21. For Z21, what we do is, we want V2 is equal to something into I1. So V2 must be expressed in terms of I1. Anyway, I2 is 0. Already we know that this I2 is 0. Okay, I2 is 0. This I1 is dividing into 2 parts, yes or no? What is the value? I1 by 2. And this is also I1 by 2. Agree all of you? Now this V2 is sum of the 2 voltages. The polarities will be like this. Okay, now V2 can be written as, use the touching concept from plus to minus. When you touch negative sign here, minus of I1 by 2 into ZB. I'm touching positive sign first here. So plus of I1 by 2 into ZA. So I got now Z, I hope you understand. Yeah, this is ZA, right? So this is ZA and this is ZB, right? Okay, ZB. So ZB minus ZA by 2 into I1. Obviously V2 by I1, V2 is equal to something into I1. This something is nothing but Z21. Therefore, Z21 is nothing but V2 by I1 is nothing but what? ZB minus ZA by 2. Agree all of you? Okay. That's it. Similarly, if you do the same process for I1 is equal to 0 and repeat the same, you already know that Z12 is equal to Z21 is equal to ZB minus ZA by 2. Why? Because there is no dependent source. Condition for reciprocity will exist and satisfy, definitely. And you apply the same logic for Z22. When you apply here, these two are in series. These two are in series. The results are parallel. Then ZA plus ZB, ZA plus ZB, parallel means ZA plus ZB by 2. And therefore, you will definitely get the same value what you got in case of Z11. Condition for symmetry is satisfied. Condition for reciprocity is obvious without even calculating that because there is no dependent source. This is how you can calculate. So finally the Z matrix is, of a lattice model of a symmetric. Okay, what is that? ZA plus ZB by 2, ZA plus ZB by 2, ZB minus ZA by 2, ZB minus ZA by 2. You must be remembering that ZB minus ZA. Clear? Ohms. Please note down. Problem. This is very important because dependent sources. Determine Y parameters of the following two-port network. With one dependent source it is given. Okay. You must be always careful when the dependent source problems are given. Remember all of you. Okay. You must be very, very careful in case of dependent source. In case of dependent source, the first method, definitions can work. No doubt in that. But the calculation may be difficult sometimes depending upon the problem given. Second method doesn't work because star delta doesn't work here because there is a dependent source. You don't know how to reduce the network. Third method is node mesh analysis will definitely work. Most of the times the star delta node mesh analysis will work. Since you are looking for Y parameters, better you deal with what? Node analysis. Yes. So node analysis says, according to node analysis, okay, you take the complete variables here. This is I2, this is V2. This is I1 and this is V1. So let me take this is 0, this is V1, this is V2, but this is definitely you must introduce one more variable and write the equations. So first equation please. This is minus I1 plus V1 by 3 plus V1 minus V3 by 6 is equal to 0. Second equation at node 2, minus I2 is equal to, or minus I2 plus V2 minus V3 by 2 is equal to 0. Third equation please, plus 2 I naught because that is the leaving current, plus V3 minus V2 by 2 plus V3 minus V1 by 6. Okay. Substitute here. Okay, already you need I naught also you require, right? So I naught. What is I naught here? Tell me. I0 is equal to V1 by 3. See, you can solve the same problem using conditions or definitions, or you can use node analysis or mesh analysis. But I'm preferring node analysis because I'm looking for Y parameters. So tell me now, how do you get it? From 4, okay, 4 in 3, you will get V3 is equal to something into V1 plus something into V2. You call it 5. Now 5 in 1 and 5 in 2, then you will get I1 is equal to something into V1 plus something into V2. And I2 is equal to something into V1 plus something into V2. Okay? So you compare, this is 6th equation, this is 7th equation. Okay? Then you compare with your standard, okay, equations of the Y parameters. Then you will get, this is nothing but Y11, Y12, Y21, Y22. You have to simplify this. I'm giving this work to you. You have to simplify this. There is nothing in this. This method looks like lengthy, but very simple. There is no doubt that you are not going to do any mistake. You have to be very careful in the calculation. That's it. Okay. So I give you the answer also here. Y is equal to, I give the answer, you can note down, 0.625 minus 0.125, 0.325, 0.125. I'm just giving the values here. Understand all of you, okay? Dependent source is given, then mostly you have to deal with either node analysis or mesh analysis. Sometimes the definitions will also work, no doubt in that. Okay? No doubt?